Hello, I'm Mrs. J, and today we're going to cover section 5.3, comparing linear and exponential equations and graphs. Linear, x is to the first power, and we usually write it in the form y equals b plus mx or mx plus b. And what it means is b, your y-intercept, plus, and then the slope is just added together x times. So it's an addition problem. Whereas exponential is multiplication, because we take c times a to the x, and a to the x means a times a times a times a times a x times. So this one's a multiplication where this is an addition. So if we look at these to see if they're linear, exponential, or neither, and identify the vertical intercept, we're looking at the first one, x is to the first power. It is not in the exponent's form, where this one is in the exponent. So this is linear. And the vertical intercept is your 5. It's the y-intercept. If you plug 0 in for x, you get 5. It's also the initial or starting amount. F of x equals 3 times 5 to the x. This is exponential. X is in the exponents. And therefore, this is exponential. Since the 5 is greater than 1, it is a growth. And the vertical intercept is 3. This is a parabola. It's quadratic. Because the x is squared, it's quadratic. And its vertical intercept would be 3. This one is exponential, and it's a growth again because 3/2 is greater than 1. I think these are all growth. Initial amount is 6, because anything to the 0 power is 1, and it leaves this value. And this 1.25n, this would be linear. Its vertical intercept is 0 because there's nothing added or subtracted on. Another thing, just put in 0 and you will see. This one, again, n is in the exponent, so it's exponential. And its growth, or vertical intercept, is 1, because if we plug in 0, we get 1. Notice this would be 1 times this. And so the vertical intercept is 1. Create a linear or exponential function. A function with an average rate of change, that's slope, that's linear. It's the same change every time, of 3, and a vertical intercept of 4. So average rate of change is your slope. And the vertical intercept, which is the starting amount, is your plus 4. A function with a growth factor, that means it's the first one's 3, the next one grows by 9, it's growing by multiples. And the vertical intercept of 4. So the initial amount is the 4, and it's 3 to the x, because this is our growth factor. Try another one. A function with a slope of 4/3 and an initial value of 5. Well, we know it's y equals mx plus b, so y equals the slope, 4/3, and the initial amount was a positive 5. Function with initial value of 5 and a growth factor of 4/3. That's exponential. So it's 5 times 4/3 to the x. A small village has an initial size of 50 people at time t equals 0, with t in years. If the population increases by 5 people per year, find an equation P of t. 5 people per year, it's the same amount each year, 5 plus 5 plus 5 plus 5. So our starting amount plus 50, or 5t. So 50 plus 5t, because it's 5 each year, 5 plus 5 plus 5. If the population increases by a factor of 1.05, so that means factor of it means multiply. Q of t equals the starting amount, 50, times the growth, 1.05 to the t. Graph both over 30 years. So if we graph using Gizmo, the first equation was y equals 50 plus 5x. And then the other one was 50 times 1.05. And I used the caret button to get up x. Now they just said 30 years, so no. There we go. I went a little lower because we do need to see where they intersect. There we go. So this is going by tens. 30 then would stop here, which I think is right after they intersect. They intersect right here. Where do the graphs intersect? 50, 1, 2. So 150, 170, 180. At about almost 3. But it's pretty close to 3. I don't know if it'll give us the exact value. That's the one it's given us. So approximately there. Yeah, that looks pretty close. Now in the next chapter we'll be able to actually solve this. But for right now we have to let the technology, because we haven't learned logs, and you need logs to solve it. Oh, that was all for that one. Page 284. Number 7. It says, find the equation of the linear function and the exponential function that are sketched through 2 points on each of the following graphs. So if we look at the graph, the linear one is the straight line. And we know our starting amount is 0. So we know it's plus 0. And then our slope 10, it goes up 10 and over 2, so 20. Oh, this is too small. Let me get a piece of paper. Because if you count your slope, you're going up 10, 20, and over 2. And that will reduce to 10x, and the 0 drops off. That would be the linear equation. The exponential, the starting amount is 0. Oh, starting amount's actually 10. So this should be a 10. Because it's starting at 10. I don't know where I was getting 0. So this is the linear. The exponential, starting amount is 10 times, we have to find a, and we have to decide if we're dividing x by anything. Now, this is 10. A growth means it needs to double, which would be 20. But it's not doubling at 20. I would go all the way to the 30. So 20 over, yeah. And that was in 2. I don't think that's right. I think it's double, triple. Because it's going from 10 to 30 in 2. So from here, we went from 10 to 30. We tripled it in 2. So we put x over 2. Let's try the next one. The linear, 1, 2, 3, starting at 100. And it's growing, so it's positive. And the slope, 1, 2, 3, 5. Okay, so starting here, 1, 2, 300, and over 3. So y equals 100 plus 100x. The other exponential still starts at 100. If we go x over 3, if we go 3 of them, it's at 100. 1, 2, 3. Again, it's tripling in 3. And that's all that's to it. So you want to see when it's growing, what it's doing, if it's tripling. And then the other way, you go in half. I don't know if there's, did I do a negative one? 11. No. Number 11 says to graph programmably if it's recommended. Create a table of values of the following functions, then graph them. So if we graph these, go ahead and write them down. Okay. The first one was y equals 6 plus 1.5x. The next one was y equals 6 times 1.5 to the, but you use the caret to get the exponent, x. Oh wow. Can we change our units? There we go. And the last one, y equals 1.5, and we're going to make 6 the growth factor. So you can kind of see the difference. The red one, it grows a little faster, whereas the blue one stayed closer to 0 and then grew fast. And then the straight line is uniform. Yeah, they just wanted us to graph it.